Okay, we've got more identities for you to learn. You don't need to memorize them. None of the identities you need to memorize. I'll give them to you on quizzes and tests, but you should be familiar with them. So the main type we're going to learn are double angle formulas. And you can probably see why they're called double angle formulas, because rather than being an identity for sine A, it's an identity for sine 2A. In other words, double the angle, right? And cos 2A and tan 2A. Now the nice thing about sine 2A and tan 2A is it's equal to just one thing. So when you see sine 2A, probably what you're going to do is you're going to switch sine 2A into 2 sine A cos A. And when you see tan 2A, you're going to switch it into this bit here. But the problem I find with cos 2A is it's equal to 3 different things. So you have to work out which is the best way to switch this into. If you're trying to get it only into terms of cosine, you probably want to put it into this middle one. But the first and the third one can be a little bit difficult to figure out which one you're using. Anyway, we'll do some examples of that. And then the other thing we have here are the power reducing formulas. The reason they're called power reducing formulas, you can probably see again, because you start with a sine squared and then you change it into something that doesn't have a squared term. Cosine squared, you change it into something with no squared. Tan squared, you switch it into something that's not squared. To tell the truth, we're not going to use power reducing formulas very much. I think the very last question in your homework has one power reducing formula, and you have to use the tan squared one. That's for your last question in the homework. But besides that, it's all double angle formulas. That's what we're going to focus on. Okay, so let's start right now. The first thing we're going to do here is we are going to try to solve this equation. Sine squared x minus cosine squared x equals 1, and we're going to do it in the interval 0 to 2 pi. Alright, well, if I look up here, by the way, there's probably different ways to do this without using double angle formulas, but let's look up the double angle formulas and see if this looks similar to anything. And what I see it's very, very similar to is this right here. Cosine squared A minus sine squared A. What we have is sine squared A, or x, minus cosine squared x. So it's kind of backwards. How could we switch it to the other way around? We could multiply everything on this side by -1, right? Because if you multiply everything by -1, the sine squared is now negative sine squared, just like it looks like there. And the negative cosine squared is now positive cosine squared. So let's write that first, the cosine squared x. This sine squared we said is now negative sine squared x. But how can we do that? How can we just go ahead and multiply everything here by -1? Well, you can do that as long as you multiply the other side by -1 too. And 1 times -1 is -1. So this is the new question we're going to solve. Now, again, this left-hand side is now exactly the same as this. So instead of having cosine squared x minus sine squared x, we can write cosine 2x equals -1. Oh, we've answered questions like this before. When is it that for what value is it that if you take the cosine of that value, you get -1? That only happens one case. It happens when the angle is 180 degrees, or pi. So does that mean x is equal to pi? No, it means 2x is equal to pi. If 2x is equal to pi, then x is equal to, divide both sides by 2, pi over 2. Are we done? No, we're not. Remember, we have, if we look at this equation right here, which we were solving, what's our period there? The period is equal to 2 pi over b, which is 2. The period's equal to pi. So, and because we have a 2 there, we know we're gonna have twice as many answers. So instead of having one answer, we're gonna have a second answer as well. How do we get it? We take the original answer, pi over 2, and we add another period, which is pi. Pi is the same as 2 pi over 2. 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. Is that still less than 2 pi? Yes, it is. 2 pi would be 4 pi over 2, and this is 3 pi. So we're done. X equals pi over 2, and x equals 3 pi over 2. Okay, next one. Cosine cubed x divided by cosine 2x plus sine squared x. We have to simplify this. Well, I see a double angle right there, that cosine 2x. So we're going to replace that cosine 2x with, oh no, which one of these are we going to replace it with? Well, let's write the top first and we'll think about this. So we have cosine cubed of x, cosine x cubed I suppose, divided by, okay, so we have cosine cubed, we have a sine squared. So what I'm thinking is, if we change this into this one, a negative sine squared, and then we have that plus sine squared. Do you see how the sine squareds are going to disappear? So this seems like the nice one to switch it into. We're going to switch this cosine 2x. We're going to use that top identity right there, which is highlighted. So instead of 2x, it's going to be cosine squared x minus sine squared x. Cosine squared x minus sine squared x. And what we still have on the bottom is plus sine squared x. And as I already alluded to, what happens on the bottom here is these two sine squared x's cancel out. Negative sine squared x plus sine squared x, none. Look what's left. Cosine cubed x, cosine squared x. In other words, you have 3. You have cosine x cubed and cosine x squared. Well, if you got 3 in the top and 2 in the bottom, you can cancel both of them out down there. 2 of them up here. What you're left with is cosine x. That is a very simple answer, and we are finished. Simplify again. Okay, we're going to try another one. Wow, sine 6x and tan 3x. There's no 2x here. We wanted sine 2x. How do we do this? Well, let's think about this for a second. We want things of the form sine 2a. Let's use an a there. Well, what could a be in this numerator position right here? What could a be so that we actually would have a double angle? What if a was equal to 3x? If a was equal to 3x and I plug that 3x in here, what would we have? We'd have sine 2 times 3x, which is sine 6x. That's exactly what we have here. So why don't we think of it that way? Instead of thinking of it as sine 6x, think of it as sine 2a, where a is 3x. I know this is a little bit confusing. So we do, in fact, even though it says sine 6x, we're going to think of it as sine 2a. So what does sine 2a simplify to? Well, if we go up and look, sine 2a equals 2 sine a cos a. So instead of sine 2a, we have 2 sine a cos a. But remember what a equaled? A equals 3x. So really what we have is 2 sine 3x cosine 3x. That's all over tan 3x. Now we could do the same sort of thing we just did, but with tan 3x, but you'd have to use an a of 3 over 2. I don't like the looks of that. Let's just leave it like this and see what happens. And then a minus 1. See, what I like about this, why I'm not going to switch this tan 3x to, why I'm not going to use a double angle identity on that, is because now we have everything with sine 3x, so we can probably do some canceling out once we put it in sine and cosine. So let's try. We leave the top the same, 2 sine 3x cos 3x all over. Well, tan 3x is the same as sine 3x over cos 3x, and we're subtracting all that by 1. Okay, well, let's simplify this. Remember, this means divide, so we have 2 sine 3x cos 3x all over 1 divided by, but I'm going to multiply and flip and multiply, reciprocal, right? So I get cos 3x over sine 3x, and once I've done that, I'll subtract the 1. Now you can see that these cancel out, just the sine 3x and the sine 3x. So what I'm left with is 2, the sine 3x gone, 2 cos 3x cos 3x. Well, that's the same as 2 cos squared 3x minus 1. Is that it? Well, let's take a look at that for a second. 2 cos squared 3x minus 1. 2 cos squared 3x minus 1. Do you see it's exactly like this? 2 cos squared 3x minus 1. So if our a was 3x, then this works completely. And what that simplifies to is cos 2x and x is, or 2a and a is 3x. So we end up with cos 2 3x, which is the same as cos 6x is our final answer. Okay, I know that's very confusing, especially this top part up here. You might have to watch that a couple times to get that. I don't know if I explained that well or not, but good luck. Okay, prove the identity. So we want the left-hand side to look like the right-hand side. Let's start with the more complicated side, which is the left side, and see what we can do. Well, we have two double angle formulas. The bottom should be no problem because it's a sine 2x, and there's only one way to switch the sine 2x. What's sine 2x switch to? It switches to 2 sine x cos x, so that's for sure 2 sine x cos x. Now on the top we have 1 plus cos 2x. Which one are we going to switch it to? Which of these three are we going to switch it to? Well, here's what I noticed this time. We have this 1 sitting here. 1. How could we get rid of that 1? Which one of these could I switch it to so the 1 would disappear? The middle one, right? Because then we'd have 1 and we'd have this minus 1. So this suggests to me that this might be the one we're going to use. Now I could be wrong, but that's the one I'm going to try here. So I'm going to switch our cos 2a to 2 cos squared a minus 1. Well, first it's 1, there's our 1, plus 2 cos squared a, or in this case x, minus 1. Alright, let's keep going. So the 1's cancel. 1 take away 1 is 0. The 2's cancel. We got a 2 on top, we got a 2 on the bottom. And the cosines, one of the cosines cancels. This cosine cancels with that cosine there. What we're left with is cosine over sine. Cosine over sine, that's the same as cotan. Guess I should have x's all these places. Cotan x. Hey, what do you know? This is exactly the same thing. We're done. Was that too confusing what I did here? I hope not. Okay, last one. Given tan x equals 3/4 in quadrant 3, find sine 2x. Alright, well, let's draw what we know. We have an angle in quadrant 3, and tan is 3/4. So opposite over adjacent is 3/4. What you might want to do is think to yourself, oh, this is actually -3, -4. That's fine if you want. It's probably safer. Or you can just remind yourself that if you're going to take sine and cos in this angle, it has to be negative. Okay, as we often do when we do these questions, let's figure out the length of the missing side here. So that's the hypotenuse. To get that, you would do -3 squared, or just 3 squared, plus 4 squared equals c squared, or if you want r, remember we actually call it r in these little drawings we make. So we have 9 plus 16 equals r squared, 25 equals r squared. Take the square root of both sides, you get 5. This is 5 right here. Okay, so what are we being asked here? We're being asked, this angle right here is x, but we're not being asked what x is. We're being asked what's the sine of 2x. So we want to know what's sine of double that amount. Like if this was x and we had another x in there, so this is 2x, what's that sine value? Well, how are we supposed to know that? We don't even know what x is, and now you want to know the sine of 2x? Seems impossible, doesn't it? But here's the thing, you do know all the expressions for sine, cos, and tan of x, and you can use your double angle formula right there. Sine 2x equals 2 sine x cos x. So this equals 2 sine x cosine x. So it equals 2 times sine x. So we're just looking at the little black triangle here. What's sine of x? Sine is opposite over hypotenuse, so -3/5. And that's multiplied by cos x. That's adjacent over hypotenuse, just of the little x, right? Not the red one. That's what we're ultimately going to find. But we're just using the little black one to help us out here. So cosine is -4/5. We're going to multiply all those. So we get 2 times -3 times -4, which is 24. And 5 times 5 is 25. Remember, this is over 1. So you end up with 24/25. I don't even know what that angle, I don't even know what the angle x is equal to. But I now know, using my double angle formula, that the sine of double that angle is 24/25. That's pretty neat.
I found a way to lose all sadness. I lost the way.